Okay. Now we do solve a few examples here. Then what is this? Calculate the resistance between the points A and B for the following resistors. Here 6 problems are given here. For that, find out the equivalent resistance between the points A and B. Let us consider the first figure here, and they have given one statement here. All resistors 500 ohm. 4 resistors are here, each of having the value 500. Then calculate equivalent resistance between the point A and B. All right. So here it is a point A and here it is the point B. All 4 resistors should be converted into the single resistors here. That we can call here as a R equivalent. You can observe here. Can you say that these 2 resistors, they are connected in series? And these 2 resistors, they are connected in series. Okay. Consider the point A, and I will take the first 2 resistors. Equivalent of those 2 resistors is what? The single resistor, that is equals to 500 plus 500 because they are connected in series. So this portion is done here. What about second portion? These 2 are series connections of the resistance that can be replaced by a single resistor. What is that value? 500 plus 500. It is between the point A and B. All right. What is 500 plus 500 here? Here it is 1 kilo ohm. And the second resistor, it is 500 plus 500. It is also the 1 kilo ohm resistor. It is the between the points A and B. But these 2 resistors should be converted into the single resistor here. It should be converted into the single resistor. Okay. Then what about these 1 k ohm and 1 k ohm? Then can you say that these 2 are connected in parallel? Obviously, because we do find 2 path for the flow of the electrons from the point A to B. Keeping that point in our mind, 1k and 1k, they are connected in a parallel. Then what is the equivalent resistance of this? Okay. I will take, now I will write here. Okay, this is not figure here. One resistor, 1k, another resistor, 1 kilo ohm between the point A and B. That should be converted into the single resistor between the point A and B. Okay, what is the formula? 1 divided by R equivalent equals to 1 divided by R1 plus 1 divided by R2. What is the R1 value here? Here it is 1k. What is R2? Here it is also the 1k. 1 divided by 1k is what here? Can you write this as 1 milli? Because 1 divided by 1k, it can be written as 1 milli, or else if you are not getting means. If you are not getting means, so what is 1k? Write 1000. Okay. So what is 1k? It is 1000. What is LCM of this? Here it is 1000. Then 1000 into 1, 1000 into 1, 1 plus 1, that is what? 2 divided by 1000. That is equals to here R equivalent. What is 2 divided by 1000? This is what? The 500. So as a result, what is R equivalent? That is equals to 500 ohm. All right. So as a result, what is the equivalent resistance? What is the equivalent resistance between the point A and B? It is 500 ohm. I hope everyone understood the problem. Please send me a reply in chat box so that I can. Number one covers both series connections as well as parallel connections. You should not disturb the point A and B. They should be in the same position. So by keeping A and B as it is, these two are in series, these two are in series. After that, those two resultant will be in parallel. All right. Then consider figure number 2. Consider figure number 2. All registers are 1K. 1K, 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 1K. Then can you tell me the answer for this? Received one answer here. Only one answer is received. 750 ohm. 3. 0.75K. One another same. These three registers, they are in series. 1K plus 1K plus 1K. Total is 3K. So these three registers can be replaced by a single resistance of value 3K. And here it is 1K. We can observe between the point A and B, 1K and 3K will be in parallel. So 1K is in parallel with 3K. As a result, we'll get 750. All right, that's good. Then what about figure number 3? What about figure number 3? I will redraw here. I do redraw the circuit. Between the point A, B. Okay. 2K, 5K. 2K, 5K, 10 and 450. 10K and 470. Okay. Then how to solve this? I can also write this as, so I do keep A as it is, B as it is. I should not do any disturbance to the nodes A and B. So between 2K and 5K, I do write in this fashion. Is there any problem for the same given problem here? Are they one another same? Only, can you say that these all things are wires? All these things are wires. Instead of connecting wires in this fashion, just a modification is done here. Both are one another same. What is the meaning? Why it is written? It is written to understand 2K and 5K, they are connected in parallel. 10K and 470K, they are connected in parallel. That's why a slight modification is done to the given figure to understand that these two are connected in parallel and these two are connected in parallel. All right. As a result, it is the point A, equivalent resistance of this, equivalent resistance of this. So I have not disturbed the nodes A and B. Then as a result, can I replace these two registers as a single registers by adding the value? Okay, are you able to understand? Have you understood the step how to calculate the resistance between the point AB? This is the step. Then I have given nodes already, take a printout of it, and I have given a space for it. Then solve right in that page only. 5, figure number 4 and figure number 6. Still some more concepts are needed to solve that. After saying those concepts, I will tell you how to solve figure number 4 and 6. Then, can a figure number 5 be solved easily? I will tell you how to solve the figure number 5. You can say all resistors values are 2.2 kilo ohm. All resistors values are 2.2 kilo ohm. Okay. What about these two resistors? These two resistors, they are connected in series. All right. As a result, what we'll get? What is equivalent circuit after first reduction? So keep the point A, B as it is. There is one resistor, one more resistor, and I can replace these two resistors into a single resistor by adding 2.2k and 2.2k. That is what 4.42k, because they are connected in series. As a result, I will get 4.4k, 2.2k, 2.2k. All these are connected in a parallel. Then get the final answer and write it in a notes. Okay. All right. I think we have done for the day. So we have solved few problems, and figure number 4 and 6 will be solved in the next class, because I want to say a few more concepts. Based on that, those they can be solved. Then take a printout of the notes provided in the WhatsApp group. Here the spaces are given. Write these solutions properly. So maintain that as a notes. Okay. Okay. Can you wind up the class today? All right. Have a nice time. Thank you.